Hi guys, I thought I would just do a little bit of review before we actually got into the solutions to those 8 IB questions. Just wanted to remind you that when you're dealing with quadratic functions, that we have 3 different forms for a quadratic function. And remember, by saying a quadratic function, we're talking about something that is in the shape of a parabola, where every single point along this parabola, each of them with the coordinates of x, y, and that the y coordinate is defined as whatever the x coordinate is when it's run through this particular equation. A, b, and c are some kinds of coefficients. Now, if you've got this c value, if it's already written in standard form with no parentheses, that c value we can see is the y-intercept. And we know that at the y-intercept, of course, the x value is equal to 0. If you substituted 0 into this function, you can imagine that these two terms would disappear. We'd be left with y is equal to c, the location of the y-intercept. Another way in which a quadratic function can be expressed is like this. This is when you factored it. So maybe you took out the common factor of a, and then you were left with some trinomial which factored into these two terms. And this is a useful form because p and q are your x-intercepts. And then there's one more way in which you can express a quadratic function. If we took our original expression, with which has been expanded in standard form, and we completed the square on it so that we could express it in what's known as vertex form, then the h and the k, these values, once you've got it in vertex form, would represent the coordinates of your vertex. And we know that if a is equal to 0, if a is greater than 0, that the parabola opens upwards. So if a is a positive number, we're smiling, and if a is a negative number, less than 0, of course, we're now facing downwards. It's a sad face, negative. So maybe I should just sort of show you a quick example where we're using real numbers. So suppose that we were dealing with the function y is equal to x squared plus 3x. Actually, I changed my mind. Let's make it a 4x. And we'll say minus 12. So if this is our function, we can immediately see, because it's been expressed in standard form, that the y-intercept is going to be equal to negative 12. We know that at a y-intercept the x value is 0, and so those will be the coordinates of the y-intercept. Now let's see if we can find out what the x-intercepts would be. Basically, what I'm trying to do right now is find out 4 critical pieces of information. I'm trying to find out what the y-intercept is. I'm trying to find out what the x-intercepts are. There are 2 of them. I'm trying to find out what the vertex is. And in fact, there's an additional piece of information, the axis of symmetry, that I also want to talk about in a minute. But we'll finish this example first. Now in my second form, then, in order to find the x-intercept, I've already got the y-intercept of negative 12. To find the x-intercept, I want to express it in factored form. So let's factor. Now because I've got a 1 in front of the x squared, this becomes a very easy trinomial to factor. And so I'm just looking for 2 numbers that will multiply to give negative 12. Meanwhile, they will add to give positive 4. And a little bit of thought about this, we realize that those 2 numbers are negative 2 and positive 6. Because we can see that the positives were dominant by 4, so 6 over 2. And so then with factors to x minus 2, x plus 6. Now you'll notice that the p and the q values are the things that are being subtracted from x. We're subtracting a 2 from the x, and so that must be one of our x-intercepts. So it's 2 2, and of course at an x-intercept the y value is 0, you'll see that in effect then we have taken the opposite of the number that is with the x. We don't take the opposite of a number that's with a y. This is one of the things that we've talked about with transformations, that we always take the opposite of what you would expect from inside the parentheses, the thing that's grouped with the x. And we'll see that a little bit later on with the vertex, where we'll take the opposite of the negative h, and our vertex will actually be at a positive h, but then the y shift we won't change at all. It will remain as a positive k. So our other x-intercept then will be the opposite of the positive 6, which becomes negative 6. And of course we could have established this by remembering that at an x-intercept we know that the y value is equal to 0. And so either x minus 2 equals 0, which yields x equals 2, or x plus 6 equals 0, which yields x equals negative 6. So these are the coordinates of the x-intercepts. Now let's move on into the third form, and I can find third form, which will give me the vertex by completing the square. So I'm going to take my original expression, and I'll focus in on the first two terms. I want to take half of my 4x term, which is a 2x, or the coefficient is a 2. I'll square it, and that's what I want to add to both sides of the equation. It looks like I forgot to add it to the left. Let's put that in. So I'm adding a 4 to both sides of the original equation. I'm adding 4 because it's equal to half of that 4 value squared. Now the nice thing about doing this is that this trinomial becomes factorable. Remember how we took half of the 4 to get 2? Becomes x plus 2, all squared. Now if you don't see that, maybe on the side, I can show you that x squared plus 4x plus 4. Think of it this way: if you're factoring it as a trinomial, that we're looking for two numbers that multiply to give 4, and they will add to give 4. Fairly quickly, I think you'll realize that those two numbers are positive 2 and positive 2, and we can express the same factor appearing twice as x plus 2 all squared. And I still have the minus 12 at the end. And now let's get y by itself by bringing the positive 4 over to the right where it becomes a negative 4. So we've got negative 12 minus 4 gives me negative 16. So now we can see then, remember that we take the opposite of that positive 2 value as our x value of the vertex. So that's going to be an x coordinate of negative 2. But this value we take exactly as it appears. There's nothing unusual about the y values. We don't switch them. Negative 16. And so look at the information that we've acquired. We've got the y-intercept, we've got the x-intercepts, and we've got the vertex. There is one more piece of information that we can find known as the axis of symmetry, and I want to return to the original the original diagram here, so we can kind of put this into some context. I'll give you three different formulas. Now remember that an axis of symmetry represents a vertical line that's going right through the vertex. And this vertical line, like any vertical line, has got the equation x equals. You must include this x equals part, or you will lose a point. So when it says axis of symmetry, it will always say, give the equation of the axis of symmetry. That means that you have to include an equals sign with the x. X equals. We're saying that every single point on this vertical line has the exact same x coordinate. That's the rule. Y can be anything, but x is always fixed at this particular value. And that's what all of these points have in common. That's the relation described by the vertical line in this axis of symmetry equation. So when you're dealing with standard form, and this will be given to you in the formula package, your axis of symmetry equation is x equals negative b, the opposite of this term, over 2 of the coefficient in front of the x squared. And just let me remind you that when you're given a problem like this, this is a 1x squared. So a is equal to 1 if you don't see a coefficient. Let's suppose that we're dealing with factored form. Suppose that you've been given the quadratic equation or quadratic function in this form. We know that due to symmetry, the axis of symmetry occurs exactly in between the two x-intercepts, p and q, because each half of the parabola should be exactly the same. So that must mean that the axis of symmetry is located at the midpoint between p and q. And so then we could describe the equation of the axis of symmetry. Again, x equals, and then you'll just have to evaluate what the midpoint of p and q is. And there's the midpoint formula. We add them together and divide by 2 to get their midpoint. And let's suppose that we've got it expressed in vertex form, either because we've completed the square or otherwise. This negative h, consider that that is the x value through which the axis of symmetry goes, or in fact it's a positive h that goes through it, right? We take the opposite. That must mean then that your axis of symmetry has got the equation x equals h, because the h coordinate, the x coordinate at the vertex, is the exact same x coordinate as every other point on this vertical line. So x equals h is another way. So we've got 3 different ways of expressing the equation of the axis of symmetry. It just depends on which of the 3 forms you currently have your quadratic function. I also wanted to show you how you could do an example like this on the calculator using a couple of different methods for some of the different information that we need to find. So I'm going to go to y equals, and I'll put in this function, x squared plus 4x, there we go, 4x minus 12, oh dear, minus 12. And when I graph this, well, we can't really see where the minimum is right now. It's obviously facing upwards, smiling positive face because of a positive value of a in front of the x squared. But I can't see the vertex. Let's adjust the window. I want to see more of the negative y region, don't I? So that I can kind of see more of what's down here. So I'll go to window and I'll adjust my y min to be, say, something like negative 20. And then I should get a good picture of all of the action in the parabola. Let's graph it again. There we go. So you can see everything that we need. We can see the 2 x-intercepts, we can see the y-intercept, we can see the vertex. So let's find out all of this information. To find out the y-intercept, you remember that the x value at the y-intercept is equal to 0. So let's go into the second trace. And the x value, so let's type in value. I don't think I've shown you this in class, but this is something you can do anytime you want to find the y value for a specific x value. So if you type in the x value, in this case for the y-intercept we know that the x value is 0, your calculator will return to you your corresponding y value. So y is equal to negative 12, and these are the coordinates of the y-intercept, exactly like we found over here, that we've got x value is 0 and a y value of negative 12 at that y-intercept. Now let's use the calculator to find the x-intercepts. So I'll say second trace. Now I want to find things called the zeros. These are the x-intercepts. So I can move my cursor to the left side of one of the x-intercepts. Let's start with the one on the left. Now it's a bit tedious, isn't it, to press the cursor so many times to finally move it over to the left. I'll show you a quicker way when I find the second 0. It doesn't matter exactly how far to the left you are, as long as you're somewhere on the left-hand side of the 0. Gotta be on the left. Let's hit enter. Now it says the right bound. I'm going to use my cursor keys to move my cursor somewhere to the right side compared to the x-intercept. That will be my right bound. And you'll see these 2 little triangles have formed. In other words, we're looking for the x-intercept that exists between my left bound and my right bound. These are the edges of the interval in which I'm exploring for x-intercept. It wants me to guess. Let's move the cursor as close as we can to the x-intercept. Now don't be fooled. This is not the exact value of the x-intercept. The cursor is very close to it, but we don't know exactly what the x-intercept is until we press enter on that guess, and we'll see that we have a 0 located at exactly -6 when y is 0. That's the second one that we had found over here. I'll show you a quicker way now to use a graph to find the other x-intercept. We'll say second trace, and again we'll use 0. But this time, instead of using the cursor keys, I'm just going to type in values of numbers that I can see are clearly on the left and on the right of the x-intercept. It's obvious that on the left-hand side of this x-intercept we have an x value of 1. Hit enter. And on the right side we clearly have an x value of 3. And I'm going to take a guess that it goes through an x-intercept of exactly 2. There's my guess. So in that case, instead of moving the cursor, I just typed in my left bound, my right bound, and my guess, and it turns out I was correct that the 0 did occur at exactly x equals 2 and y equals 0, and those are the x-intercepts. In fact, there's a third way that we could have found the x-intercepts. So we've already got the factoring method. We've already got now the graphing on the calculator method. And I'll show you a third way that you could have done it. You'll remember that at an x-intercept, we know that the y value is equal to 0. So if this y value is equal to 0, what we can do with this particular equation is use polyroot finder. So I'll press apps, and I'll go down to my polysimilt, and option 1 is my polyroot finder. And so I'll type in, it is a second degree equation because I'm dealing with an x squared, that's a power of 2, so the order is 2. So we'll say next and we'll type in the 3 coefficients. It's 1x squared, 4x, and -12 as the constant. Let's press the solve button, and this will give you the two values, -6 and -2, where our x-intercepts are located. Alright, I'm going to quit this app because I want to find the vertex now. You remember that we've already got this graph of our parabola. I want to find the location of this. Is this a minimum or a maximum? Now, because the parabola is opening upwards, this is clearly a minimum y value. It's as low as my y value ever gets, the minimum value. Of course, if the parabola had been in the other direction, well then I would have a maximum. But here I've got a minimum, so when I say second and trace, I'll go down to minimum, and again the calculator will ask me for the left bound, the right bound, and a guess. I'm going to use the quicker method. I think that 1, 2, 3, 4, 5, I think -5 is safely on the left of my minimum, and I would think that 0 is safely on the right of my minimum, and I'm going to take a guess that my minimum occurs at -1.5. In fact, the minimum occurs when x is -2 and y is -16, exactly as I had found here. So I've basically summarized the entire topic of quadratic functions during this little presentation. I hope you'll find it useful. On the next video, I'm actually going to move on to the first few questions that you were assigned on the review to prepare you for the upcoming quiz.